Okay, so let's extend this problem to multi-point charges, meaning there's more than one charge in our system. So here, let us consider two like charges, and for simplicity's sake, let's say both of these charges are positive. So let's consider over here 2 points in space. Let's call them A and B. And we have the distances from each of these points to our charges defined as follow in terms of a unit length called A. For example, the distance between the two charges over here, which I call Q, and that is positive, is A plus 2A, meaning the distances between the charges is 4A, and the distance between midway between the two charges to point A is A. And B just happens to be to the left of point A by a unit length of A. Okay, so we're gonna work through finding what the electric field is at point A and B. So for simplicity's sake, let's simplify the problem for the time being and just look at point A. So if we just look at point A and we consider that these are positive charges, the electric field due to each of these is pointing away from the charge at point A. So let's label this charge over here Q1 and label this charge over here Q2. Drawing a line from each of these charges, we see that the electric field over here at point A for Q1 points that way, and for Q2 it points this way. And we'll call these electric fields E1 and E2 respectively. Okay, so let's consider now what they look like in terms of vectors. So let's blow this picture up a little bit. Okay, now here, if we just look at E1, as we know prior, that there must be an x and y component to these vectors. Having troubles deciding where I want to put this point. So now we see here, for E1, there's a y component. We'll call that E1y. For E2, E1 again, there's also this x component going in that direction. Likewise, for E2, we see this component is in that direction, and that component is in this direction. Okay, so now we see over here that we're going to do some vector addition. So let's just write out what that vector equation ought to look like. So moving over to the side, we see the electric field vector at point A will equal to the sum of the electric field vectors due to charge 1 plus that due to charge 2. We can also just as well write this as the electric field at point A in the x direction, I hat, plus the electric field in the y direction at point A, j hat, and we know that this is also equal to the sum of the electric fields in the x direction, I hat, plus the sum of the electric fields in the y direction, j hat. Okay, so we'll address some of the more finer details now in a later video.